we are looking at analytical geometry, equation of a straight line. There's two ways that we normally use in determining the equation of a straight line. The first one is the gradient point form. That is y minus y1 is equal to the gradient multiplied by x minus x1, and this x1 and x1 and y1, that is the coordinate x1 and y1. So to determine the equation of a straight line, we need two things. The first thing that we need is the gradient of that particular line, and the second thing that we need is a coordinate on that particular line. And then we substitute these two into this formula: y minus y1 is equal to gradient multiplied by the bracket of x minus x1, where your x1 and the y1 are coming from the coordinate on that particular straight line. So if you are given a coordinate and gradient, you just substitute. But if you are given two coordinates, you have to first determine the gradient and then you substitute. The other way of doing it is gradient intercept form. This you make use of it when you have the y-intercept. Y is equal to mx plus c, where your c there is your y-intercept, your m is the gradient. All right. Let's determine the equation of straight lines for these two questions when you are given a point and the gradient. Determine the equation of a straight line passing through the point 1:2 with a gradient of 4. All right, so our gradient is 4, that is the value of m, and this is x1 s2 y1. x1 s2 y1. There we are. So substituting into this formula, that is going to be y minus your y1 there is the y value for the coordinate, that is 2, is equal to our gradient is 4 multiplied by the bracket of x minus, you take the x coordinate, that is your x1 there, and then you simplify. Y minus 2 is equal to, distribute this one, 4x minus 4, and then your y is equal to 4x minus 4 plus 2. So the equation is 4, y is equal to 4x minus 2. And the equation, when simplified, is in the form y is equal to mx plus c, where this is your gradient and this is your y-intercept. We could have used this equation by substituting there. We have our gradient, so it's y is equal to 4x plus c, and then we make use of the coordinate to determine the value of c. Substitute that coordinate into this one, so we have 2 is equal to 4 bracket, your x there is a 1 plus c. So this 4 goes to the other side. We have 2 minus 4 is equal to c. So your c there is equal to negative 2. So you come back here. In place of that c, you write the value of c to have y is equal to 4x minus 2. All right, you can pause the video and try the second one to see if you can do it. But in doing it, I advise you to just stick to one method, but it's good to know both methods. All right, for the second one, this is our gradient and this is the coordinate on that line. Substituting into this gradient point form, that's y minus our y is a 1 is equal to, the gradient is negative 13 bracket x minus a negative 1 there. So this is y, take this one to the other side, is equal to, distribute here. Remember, this is a double negative that gives you positive, so it's negative 13 times x, it's negative 13x, and negative 13 times a positive 1 here is negative 13, and the negative 1 comes to the other side and becomes positive 1. So the equation is y is equal to negative 13x minus 12. That is the equation. This is when you are given a point and the gradient. Now for the second one, when you are given 2 points, this time we have 2 points, but we do not have gradient. Find the equation of the straight line passing through P and Q. So the first thing here is to determine your gradient by y2 minus y1 over x2 minus x1. So this is equal to, I'll take this as 2, this as 1. So that is my y2 there is negative 5 minus a 4 all over negative 1 there minus a 5. I've substituted the 2 points. This one gives me my y2 and x2. This one gives me my x1 and x2. So this is equal to, this one gives us a 9, negative 9 over negative 6. So this is going to be equal to negative divided by negative is positive. 3 goes into this one, 3 times into this one, 2 times. So this is my gradient. Then you choose any one of these 2 points to substitute. I'm going to choose this one here. So I have y minus, this is my y1 there, that is a 4, is equal to my gradient is 3 over 2 bracket x minus the x1 is a 5 there, and then we have y minus 4 is equal to 3 over 2x. Multiply this one, we have negative 15 over 2. And then your 4 goes to the other side, we have y is equal to 3 over 2x minus 15 over 2 is negative, it becomes positive 4. This 4 can be written as 8 over 2. I want it to have the same denominator as this one, so we have negative 15 over x plus 8 over 2. That is equal to 3 over 2x minus 15 plus 8, that is negative 7, so it's minus 7 over 2. That is our equation there. You can pause the video and try this one and see if you'll be able to give the correct equation. Determine the equation of a straight line through the points this and that. The first step there is to determine the gradient. Let me take this as x2 s2 y2 here, and then this one is x1 s2 y1, right? So my x2 is negative 7 minus my x1 there is 8, which is a positive, and then this is y2 minus y1, and then my x2 now is negative 2 minus the x1 there is a 3, so this is equal to negative 15 over negative 5, which is equal to positive 3, and then choose any one of the 2 points, substitute into the formula y minus y1 is equal to m bracket x minus x1. So my y minus, I'm choosing, let me choose this point this time. So my y1 there is a negative 7, so it's minus negative 7 is equal to, my gradient there is 3 bracket x minus, we're making use of a negative 2 there, so it's negative 2 in bracket, and then you close that big bracket. So this is y plus 7 is equal to 3 bracket x plus 2, and then this is equal to, distribute, this is 3x and then plus 6. The positive 7 goes to the other side to be negative 7, and we are left with a y here. So the gradient y is equal to 3x minus 1. That is the gradient. All right, that's all I have for you for the equation of a straight line.